In this topic, we will study about the need of protection of SCR. As we know that the SCR is a 4-layer, 3-junction, 3-terminal device. 4-layer means PN, junction J1, J2, J3 and 3-terminal anode, cathode and gate. The SCR is a very delicate device. So, we have to use it in its specific rating to get our desired or required output. SCR may faces some abnormal conditions during its operation due to the rate of rise of voltage, rate of rise of current, over voltage, over current, junction temperature. Now, due to this abnormal condition, the SCR may permanently damage. So, for the reliable operation of the circuits, the protection is required for the SCR. In this video, we will learn about dV by dt protection of SCR. The rate of rise of anode to cathode voltage dV by dt must be in specified limit. The higher value of dV by dt may SCR turn on even when gate current is 0. This is called false triggering of SCR. To avoid this false triggering of SCR, it requires protection. As shown in this figure, forward voltage applied to the thyristor or SCR. That means the anode terminal of thyristor is connected to the positive terminal of the supply and the cathode terminal of the SCR or thyristor is connected to the negative terminal of the supply. The junction J1 and J3 will forward bias and junction J2 will reverse bias. The junction J2 behave as a capacitor due to the charges existing on the both side of depletion layer. Then one side positive charges and another side negative charges are induced. A charging current, say I charging, will flow through the SCR. If V is the voltage across the junction J2, then the current passing through this junction is given as I charge is equal to dq by dt. That means rate of change of charge. But as we know, the Q is equal to C into V, where C is the capacitance of the junction J2 and V is the voltage applied to the circuit. So now just put the value of Q in this equation, d by dt Cj2V. Now differentiate it. Cj2 take common dV by dt plus next V take constant dCj2 by dt. Now Cj2 is a constant. That means your equation becomes I charge is equal to Cj2 dV by dt. So I can write this equation in this manner. I is directly proportional to dV by dt. That means the current passing through SCR I charge is directly proportional to the rate of change of voltage. If the rate of change of voltage anode to cathode is high, the current through junction J2, the capacitor may be sufficient to turn on the thyristor or damage the thyristor. So the thyristor must be protected against maximum permissible dV by dt of SCR, which is given by manufacturer. The typical value dV by dt are 50 volt per microsecond to 500 volt per microsecond. A snubber circuit is used to provide dV by dt protection for the SCR. Snubber circuit. Snubber circuit consists of a capacitor Cs connected in series with resistance Rs. The series combination of Rs and Cs is known as a snubber circuit. Now this series combination is connected in parallel with thyristors which require protection. Now as shown in figure, when switch S is closed, the sudden voltage Vs appear across this circuit. At that time, this capacitor Cs behave as a short circuit. Therefore, the voltage available across this SCR is 0 and this capacitor Cs is charged through Rs. So the voltage, therefore, the voltage across this SCR is increased at slow rate, which is less than the specified maximum limit of dV by dt of SCR as given by the manufacturer. Now, here the question is arised that the capacitor Cs is enough to prevent dV by dt. So, what is the need of this series resistance Rs putting in the circuit? So, before the SCR turn on by gate pulse, this capacitor Cs charge at fully voltage Vs. Upper plate becomes positive and lower plate becomes negative. Now when the SCR is turned on by applying gate pulse to the thyristor, the capacitor is discharged through SCR. This discharging current passing through this SCR, and the value of this current according to Ohm's law, I charge is equal to Vs divided by resistance of SCR plus resistance of capacitor, and the value of this resistance is very low. So the high discharge current flow through this SCR, which may destroy or damage the SCR. Now, in order to limit the magnitude of this discharge currents is by putting series resistance Rs in this circuit. So ultimately it reduces the di by dt. Second, di by dt protection of SCR. When thyristor is in forward bias and it is turned on by positive gate signal applied to the thyristor, that there will flow anode current. Now this anode current or charge carriers is require some time to spread whole cross section area of gate cathode junction. If the rate of rise of anode current is greater than the spread time of velocity of charge, it may create hot spots in the gate cathode junction which may damage the SCR. Therefore, the rate of rise of anode current at the time of turn on must be kept below the specified limit which is given by manufacturer. For that, we are inserting one inductor in series with the SCR, and this inductor is called as a di by dt inductor. As we know that the property of inductor which opposes the rate of change of current. So this inductor is not allowed to rise in anode current, and the typical value of this di by dt are 20 to 500 ampere per microsecond. So you can say that these inductors provide protections against di by dt.